Hi, welcome to AP Stats Quidio number 2. In this quidio, we're going to be looking at a scatter plot of the height of father in inches and the height of women in inches. Part A. Draw the least squares regression line on the scatter plot above. You draw the least squares regression line by either plugging the equation into your calculator and looking at the table. Here's the equation right here. Or you can plug in a value for x and then get y. So the equation is the probability of y equals 35.1 plus 0.427x. I chose to plug in x values to get the y values. So I plugged in 50 since it's one of the first x values and got 56.45 for the y value. And I plotted a point there. I then went down to 86 to get an endpoint, and I got up here a y value of 71.822. And then I found a middle-ish point at 70, and I got a y value of 64.99 and plotted my point up here. Then I simply connected those dots to make my least squares regression line. Part B. One father's height was x equals 67 inches, and his daughter's height was y equals 61 inches. Circle the point on the scatter plot above that represents this pair, and draw the segment on the scatter plot that corresponds to the residual for it. Give a numerical value for the residual. So I first started off by circling the point and then drawing the segment on the scatter plot that corresponded to the residual for it. So here you can see is the point x equals 67 and y equals 61, and I circled that and then drew the line segment. Then we go over here to our equation. So first we're going to find the residual, which is y observed of the data, minus y hat, which is the predicted point on the line. So our y value is 61. Then we're going to find the predicted y value. So we do that by plugging in the equation a plus bx, which is 35.1 plus 0.427 times 67, which is the father's height. And you get 63.709. Then we're going to plug this simply into the equation y minus predicted y hat. So then you have 61 minus 63.709 equals negative 2.709 inches. So basically this is just telling us that the point is under the line by 2.709 inches, which is an overestimate ultimately. Then we go on to part C. Part C says, suppose the point x equals 84, y equals 71 is added to the data set. Would the slope of the least squares regression line increase, decrease, or remain about the same? So first I started off by plotting that point x equals 84 and y equals 71 right here. And as you can see, it falls right on my least squares regression line. This means that it'll stay the same. The point is on the line of regression, therefore the slope will not increase or decrease, keeping it the same. It will not change direction of the line, only the range of values. We then go on to part D. Would the correlation increase, decrease, or remain about the same? Explain. The correlation would increase because it is on the line, which means that there is more data on the line, proving it is truly the line of best fit and makes the correlation stronger. We can see that we talked about graphs like these in Unit 1, where we discussed scatter plots and how we can describe them. One of the ways is range. It increases in this case with the new higher points added. You can also find the mean of the men's height, which is 69.45, and the mean of the women's height, which is lower at 64.39 inches. There also doesn't seem to be any potential outliers. Thank you for watching.